Chapter 6, 6, and 6, 7, review for your quiz. I'm just going to do some examples to get you ready for your quiz. Let's just go ahead and get started. First of all, let f of x equal x plus 5 and g of x equal x squared minus 25. What is the domain of f over g of x? So we're dividing here. We're doing a function operation. So the function f of x over g of x, we're going to put f, which is x plus 5, over g, which is x squared minus 25. Now, since this is not simplified, because we can factor the denominator here, we're going to go ahead and defactor that. So I have x plus 5, and then two numbers that multiply to negative 25, but add to 0, are x minus 5 and x plus 5. Once I get to this point, simplify. X plus 5 and x plus 5 are both going to cancel, so I'm left with 1 over x minus 5. So f over g of x equals 1 over x minus 5. Okay, and then it asks what the domain is. Well, the domain, you can also graph it, but we don't really need to graph it because we know that there's two things that x cannot be. It's going to be all real numbers, except for x right here cannot be positive 5 and x cannot be negative 5, because we cannot have a 0 in the denominator. If the domain x is 5, we have 5 minus 5, which is 0. 0 times x plus 5, or 5, is going to be 0, and you cannot divide by 0. So the domain is all real numbers, so x such that x is in the set of all real numbers, but x cannot be, wrong symbol, 5 or negative 5. Next one. So now we're going to go ahead and do the same thing here, except now I'm dividing p over q. Well, p is x squared minus 5x minus 36 over x minus 9. First thing I need to do is factor my numerator. So I have two numbers that multiply to negative 36 that add to negative 5. They are going to be negative 9 and positive 4. So I have x minus 9 and x plus 4 over x minus 9. And there we have it again. We can cancel out our x minus 9s. So p over q of x is equal to x plus 4. However, the domain is all real numbers. But what can x not be? What would make the denominator equal to 0 when x equals what? 9. X cannot be 9. Let's go ahead and do the next one. We have let f of x equal the square root of x minus 4 and g of x equal x plus 6. What are f plus g of x and f minus g of x? Well, f plus g of x, I'm just going to go ahead and take the function f, which is the square root of x minus 4, and add it to x plus 6, and then combine any like terms that are possible. The only like terms I have here are my minus 4 and plus 6. So I have, that gives me 2, positive 2. So I still just have the square root of x plus 2. And that's going to be your final answer. Now when we subtract, don't forget, the most common mistake students make when they subtract is they forget to distribute the minus sign. So remember, f, which is the square root of x minus 4, minus g, which is x plus 6, I have to distribute that minus sign. So I have the square root of x minus 4 minus x minus 6. So now when you combine those like terms, we're going to get negative 10. So we have the square root of x minus 10. That'll give us f minus g of x. Let g of x equal x minus 3 and h of x equal x squared plus 6. What is h of g of 1? Now remember, this is the same thing as h of g of 1. Okay, so we're always going to start with the inside out. So I'm going to find out what g of 1 is first. So I'm going to take 1 and plug it into the g function. So I have 1 minus 3, which is negative 2. Since g of 1 is negative 2, I'm going to now find h of negative 2, switch. I'm going to go to the h function. I have negative 2 squared plus 6, which is 4 plus 6, and I have 10. So we would say h of g 1 equals 10. Let f of x equal x minus 2 and g of x equal x cubed. What is f of g of 2? Same thing. I'm going to go ahead and start with my g function, which is this one, g of 2. Work from the inside out. G of 2 is going to be 2 cubed, which is 2 times 2, which is 4 times 2 is 8. Take that 8 and find f of 8. So I'm going to take the f function, plug in 8, which gives me 8 minus 2, which is 6. So we would say f of g of 2 equals 6. All right, f of x equals negative 3x squared minus or plus 4x minus 10. G of x equals 2x plus 5. F of g of 4. Remember, the first step is to do this one, inside out. So we're going to find g of 4 first. G of 4 is just 2 times 4 plus 5, which is 8 plus 5, and that gives me 13. Since g of 4 is 13, we're now going to take our 13 and plug it in for f. So it's f of 13, since that's our second one. F of 13, which gives me negative 3 times 13 squared plus 4 times 13 minus 10. So we have to have square 13, which gives me, I think, 169, I believe. And then this one is 52 minus 10. I'll have to check my math here in a minute. So I have 169 plus 52. Actually, it would be, if I combine these two, it would be 42. So 169 plus 42 equals 211. So we would say f of g of 4 equals 211. I'm going to go ahead and check my math, make sure I didn't make any computation errors with the calculator. I did actually make an error. I forgot this 3 right here. So let's go ahead and fix that. So I have 3 times 169. And this one was correct. That one is 52 minus 10. And then I have to take 3 times 169, which gives me 507. So 507 plus 52 minus 10 would give me 559 minus 10, which is 549. All right, now we got it right. And then g of f of x. Remember, if I don't have a number, that means I have to take the entire f function and put it in place of the x of the g function. Put the f inside of the g function. So I have 2, and then instead of an x, I'm going to put the entire function in, negative 3x squared plus 4x minus 10. And then plus 5. And then just simplify. Distribute. So I have negative 6x squared plus 8x minus 20 plus 5. Combine like terms, which are just these two. So negative 6x squared plus 8x minus 15 is g of f of x. Got the negative there. All right, for f of x equals 4x minus 9 and g of x equals x plus 9 over 4, find the following functions. F of g of x. So first thing we have to do is we have to take the entire g function, put it in for x. So I'm going to go ahead, I have 4, and then instead of x, I'm going to put in x plus 9 over 4, and then I have minus 9, and simplify. So cancels, so I have x plus 9 minus 9. So that gives me plus 9 minus 9 also cancels, so I just have x. So what does that tell me? If I compose two functions and I just get x back, or they completely cancel each other out, that tells me that they're inverses of each other. And if they are inverses of each other, what does that say about going the other way and b here? Well, that just means I'm going to get x. Since they're inverses, even if I compose them the other way, I'm going to get that. If I keep composing and I put in 8, what's going to come out? 8. Same thing the other way. If I put in 8, I'm going to get 8. Okay? This problem just goes to show you that inverse functions, when composed, they cancel each other out, and you're just going to get back what you had. All right, find the inverse and state the domain of the inverse function. And is it one-to-one? So here's my f of x function, so I need to find the inverse. Step 1, change it to a y, the f of x. Step 2, flip x and y. And then, oh, forgot my y there. Subtract 3. So I have x minus 3 equals negative y, divided by negative 1. So I have negative x plus 3 equals positive y. Change your y to f inverse of x equals negative x plus 3. And there's your inverse function. Then what is the domain? Well, you have to, if you need to graph it, go ahead and graph it, which we can do that. We don't have it open yet, but we can go ahead and open it. Go ahead and graph it. So that function was negative x plus 3, and if you remember, this is just going to be a line. So, if I can get it to pop up here, negative x plus 3. Yes, it's just a line. So what's your domain? Negative infinity to positive infinity. And if you don't have to graph it, or you could say all real numbers or all possible solutions, or there's lots of different ways to write it. And is it one-to-one? Well, the inverse is a function, and so is the original one. That's also a function because they're both lines. So is it one-to-one? Yes, it is one-to-one. Find the inverse and state the domain of its inverse, and is it one-to-one? Well, let's go ahead and look at this. If I were to graph this, and we talked about this when we did our notes, okay, what would it look like? We would just have a line that goes out to the side because there is no plus or minus. But let's go ahead and find the inverse. So we have y equals the square root of x plus 3. Then I'm going to flip x and y, so x equals the square root of y plus 3. How do I get rid of a square root? I'm going to square both sides. That cancels out my square root, so I have x squared equals y plus 3. And now I'm going to subtract 3. So I have x squared minus 3 equals y. Change it to inverse. F inverse, oh, not f. We're talking about n here. My fault. Because it started with an n. So n inverse of x equals x squared minus 3. Now if we were to graph that, we would get this, okay? And it asks, what is the domain of the inverse function? The domain of this function, does it ever stop going left? Does it ever stop going right? No, so all real numbers. The domain is all real numbers. Okay, and is it one-to-one? Well, if we were to reflect that over the y equals x axis, we would say no. However, because of the way it's written, there is no plus or minus. It can be because the inverse this one would be a function because there is no plus or minus. So we would say all right, find the inverse and state the domain of the inverse function, not the range. We want the range. And is it one-to-one? So I'm going to change this to y. Okay, flip x and y. Solve for y, subtract 1. So I have x minus 1 equals 3y squared. And then divide by 3. Go ahead and distribute it. So we have 1/3 y minus 1/3 equals y squared. Then we have to find the square root. And remember, when we're solving an equation and we find the square root, we need a plus or minus. So we have, oh, why did I change that one to a y? Should be an x. Okay, so we have, there we go, plus or minus the square root of 1/3 x minus 1/3 equals y. That's a plus or minus sign, by the way. Handwriting getting pretty sloppy. Here we go. And what is the domain? Well, this one you're going to have to graph, unless anybody knows what that one looks like. Okay, and so in order to graph this one, you're going to need to graph both the positive and the negative. So the positive is just going to look like this. You have the square root of 1/3 x. Is it minus or plus 1/3? Minus 1/3. So you can see it pop up. And then if you want to, you can just select that entire, and copy it, maybe, and paste it down here, and put a negative in front so that you have the positive and the negative. And there's the negative. Okay, so the domain is going to start at, looks like, 1 and go to positive infinity. So we'd say domain is going to be x such that x is greater than or equal to 1. All right, find the inverse and then state the domain and range of the inverse function. Okay, well, I'm going to flip x and y, so I have y equals, I'm going to change f of x to y, so y equals -6 over x minus 3. Flip them, so x equals -6 over y minus 3. Now, how do I do this? Well, to get rid of this, I'm just going to multiply both sides by y minus 3, so I can cancel them out when it's in the denominator. So I'm left with -6, and then I have y minus 3 times x. And I'm not going to distribute that because I want to get rid of x. I want to solve for y, so I'm going to divide both sides by x. So I have y minus 3 equals -6 over x, and then I'm going to add 3. So y equals -6 over x plus 3. Okay? Well, if you were to graph that, which I went ahead and did that, and we can put that in there if you want, but it's going to look like this. And right here you'll see that this graph goes from -infinity and then it stops. Where does it stop? What can x not be? Well, if you look, what would x not be allowed to be? X cannot be 0. So you could say it's all real numbers except x cannot be 0. Or you can say it goes to -infinity to 0, and then it starts from 0 and goes to positive infinity. But it never actually equals 0. Okay? And then we don't need the range. And that's it.